Hi, this is Jack Jackson. We're going to be looking at solving right triangles today. So we have a number of techniques and facts, theorems that give us some things that we can use to help solve right triangles. We know that the angles in any triangle always add up to 180 degrees or pi radians. So that means that the two acute angles must add up to 90 degrees, since the right angle, of course, takes up 90 degrees of that 180. Leaving A plus B, all the angle measures, to add up to 90 degrees. We also have the Pythagorean theorem. If we have a right triangle, that a squared plus b squared equals c squared for the legs. And then, of course, we have our trig ratios. The sine of angle A is opposite over a hypotenuse. That would be A over C. That's also the cosine of angle B, which would be adjacent over hypotenuse. That would be A over C either way. The cosine of angle A then is adjacent over hypotenuse, so that would be B over C, or that's the sine of angle B, which is opposite over hypotenuse, so that would be B over C either way. The tangent of angle A is, that's backwards, let's get that right. Tangent of angle A is opposite, which is A, over adjacent, which is B, and the tangent of angle B is opposite, which is B, over adjacent, which would be A, adjacent leg. So fix that typo. And then since the cosine of angle A is B over C, then to find angle A, we could do the inverse cosine of B over C if we know B and C. On the other hand, if we know A and C, the sine of angle A is A over C, so the inverse sine of A over C is A. And if we know A and B, okay, we have it right this time. The tangent of angle A is A over B, so the inverse tangent of A over B is A. Similarly, the cosine of B is A over C, so inverse cosine of A over C will give you angle B. B over C is the sine of angle B, so the inverse sine of B over C will give you the angle B. And B over A is the tangent of B, so the inverse tangent of that will give you angle B. So if you know B over A, use the inverse tangent. If you know B and C, use the inverse sine. If you know A and C, use inverse cosine. And so this gives us some things that we can do for right triangles. And then one more thing, of course, that we know for right triangles, let me add that here, is the area. And the area, K, equals 1/2 okay, the base times the height, and the base and the height are both legs here. So they're both A and B are both one's the base and one's the height. So this will be 1/2 AB, and that's the area K, capital K. Okay, and so we have this this basic result here, which allows us to compute the area. So we're going to be using these basic formulas. And this is one of the pages in my Sketch Trigonometry Ultimate. And in fact, this is a page that was just added recently, so if you have downloaded this before, you may want to download this again. So there are actually 8 cases where we can know some information. So basically, if we know two legs, the hypotenuse of the leg, angle in the adjacent side, the angle in the opposite side, the angle in the hypotenuse. In other words, if we know one leg and one side in any other piece of information, we can certainly do that, even if it's a leg in the area or the hypotenuse in the area. And we can also do it without knowing an angle. I mean, without knowing a side. If we have the area in an angle, we can also figure out the everything. And so we're going to solve the triangle. And so solving the triangle means finding the lengths of all sides A, B, and C, and finding the angles, capital A, B, and C, and then also the area. So we're going to have a video for each of the cases. This one is going to start with the leg case. So suppose we know two legs. Okay, so let's suppose we know the legs are 4 and 7 here, let's say, for example. Well, this sketch will construct this to scale. Let's change it a little bit. How about 4 and 6? So just type in the box and enter, and that will change everything dynamically. So let's see how we can go about doing this. Well, we can actually start by finding the side, the hypotenuse, or we can start by finding the angles. Either one can go first. I'm going to start by finding the angles first. Now, if we're going to try to find angle B, look what we have. We have the opposite side and the adjacent side. Opposite and adjacent, that ratio is tangent. So we know the tangent of angle B is the opposite over adjacent, so that's B over A. And so the angle B is then the inverse tangent of B over A. So that's 6 centimeters over 4 centimeters. And do the inverse tangent of that, and we get 56 point something degrees. Okay, so let me just show you how to do that on the calculator real fast as well. So this sketch will actually shows you the steps and shows you the computations. Let's clear this all out. And since on this one here we're going to be doing things in degrees, so let me go ahead and just put it in degree mode, so when it does an inverse trig function it will come out in degrees. Always important to know where your calculator is, what mode. So if we do second tangent, that will be inverse tangent, and then it's of 6 over 4, and enter, and that's 56.30993247 degrees. Basically what we have here. Okay, now of course A plus B is 90 degrees, so A is just 90 degrees minus B, so we just do 90 minus our previous answer to find B, which is 33.69 degrees. And then to find side C, we can use the Pythagorean theorem. A squared plus B squared equals C squared, so C is the square root of A squared plus B squared. Normally when you square root both sides you have a plus or minus, but C is a length, so it can't be a minus, it can't be a negative. So just plug those in, our 4 and our 6 for A and B, and again I'll do it on the calculator. So that's the square root of 4 square plus 6 square, close parentheses, and enter, and we get that. It's square root of 52 would be an exact value if the 4 and the 6 were exact, and approximately then it's 72 point whatever. All of this sketch is going to assume everything's an approximation. Then finally we're going to find the area, which is 1/2 A times B. A is 4, B is 6, so it's 1/2 times 4 is 2 times 6 is 12, so that's 12 square centimeters. So there's an example of the leg case. Why don't you do one now, and we'll check it here in just a minute. So let's do one where the legs are, of course this is a right angle here. We're assuming in all of these cases here, we're assuming that that angle C is 90 degrees all of the time. Okay, so solving right triangles. We'll learn in our last unit how to do solving triangles that are not necessarily right triangles. Okay, so let's do one here. How about the sides of 3 and 7? So you do one where A is 3, B is 7. When you get it solved, then you come back here to the video and check it out. Check out your work to make sure you've done it correctly. So press pause now. Okay, now that you're back, we can type our values in. 3 here and 7 here. And now there it's drawn to scale. Of course you could draw this with your protractor and compass to sort of check things visually as well. Use your protractor to make a right angle here, then go out 3 here and 7 here. Complete your triangle and measure it. Okay, once again, the tangent of angle B is B over A. So B is the inverse tangent of B over A, which is inverse tangent of 7 over 3. On our calculator, that's inverse tangent 7 over 3 like this. And notice that's 66.8 degrees. Make sure you're in degree mode if you want your answer in degrees. If you want it in radians, then put it in radian mode. Then do 90 degrees minus that previous answer, and that will be the degree measure of the angle A, about 23.2 degrees. And then define C, use the Pythagorean theorem. C is the square root of A squared plus B squared. And so that would be the square root of 3 square plus 7 square. And that's approximately 7.616, and which is what's given here. And finally, do the area. It's 1/2 A times B. So 3 times 7 is 21. Half of that is 10.5. So it's 10.5 square centimeters. And that gives you a couple of examples. You can come back to this sketchpad sketch and check any problem that you want to. So you can practice this as much as you want and check your answers here with this sketch. Of course, you won't be able to use this sketch on exams, so be sure that you practice doing this until you can get really good at this. This first unit, really having a really good grasp of how to solve triangles and use these different trig ratios and Pythagorean theorem and angle sum theorem, that's going to be very important because we're going to kind of build on this the whole semester. So very important that you get really good at this. Come back for the next video. We'll do a short video on each case now from here on out.